All right, the goal of today, we are now in lesson 10 of unit 2, is to investigate what graphs can tell us about the equations and the relationships that they represent. Remember that what we are doing is problem-based learning. So it's learning through actual me giving you an assigned task, and then we look at maybe some trends, some relationships that come from that. I know first hour some kids are getting a little frustrated because they didn't know what to do, but just ask and I can give you like a little bit more direction. I won't necessarily give you the answer right away, but I'll lead you more toward that end goal, which is seeing those relationships in equations and the graphs that represent them. You'll know that you're successful if you can do each of these. And I know they're getting a little bit longer and more wordy, but it's to help you verbalize what you are missing. So if after the lesson, you can't describe connections between an equation that looks like this and the features of its graph and the rate of change in that situation, then you could say, hey, Ms. Medina, I need help with the first learning target. Or you need help with graphing a linear equation in the form ax plus by. All right, and then the last learning target is understanding that rewriting the equations for a line in different forms can make it easier to find certain kinds of information about the relationship. I am recording right now. I'll link it in the slides later. The puzzle piece will be for lesson 10. It's possible you might have to do it as homework today. So far, first hour didn't have a lot of time. Today, I'll try to cut down on my copying to give you guys more time in the activity and for us to review it. And we'll see if we have time for you guys. Pretty soon, I'm going to stop reminding you about this, that this is basically a way to boost your score. And it is by completing this remediation assignment. I know some of you have completed it since the last time we talked about it and are getting those entered and adjusted. But even if you come and do test corrections or come and do a retake, I will still also adjust the score for you. So there's plenty of ways to improve from your Unit 1 test score. Ordinarily, we don't necessarily let you test for Unit 1 forever. So we're going to try and like cut down on you waiting. Usually the longer you wait, the worse that you do on the read. So try to get it done by September 30th. By Unit 2, you should have already retaken Unit 1. Like I technically don't have to let you retake Unit 1 after that. So you need to get that done as soon as possible. Just so you know, if retakes aren't for you, you could also do test corrections for half credit back. So quizzes you can correct from home on a separate piece of paper. Tests, like unit tests, will have to be done in this room to keep it more secure. And what I'm looking for is not just a correct answer, but an explanation too. So some of the test corrections that I've graded, I've not been able to reward points because there was no work shown or explanation. Like, how do I know that you didn't just get that answer from a friend? Or like in my scribe, I let my students work together on the test correction. But you need to actually like learn from your mistakes. But show me that you've learned, even if someone is helping you by showing the work and or the explanation. You can't. So just so you know, that is another way to improve the grade. The next quiz may be tomorrow. We might have to push it to Friday. We'll just have to see. But it's on lesson 6 through 11. So they are on lesson 10, so we're getting closer. They'll look to be how it will be. So questions on any of that so far? All right, so then now on to the warm-up. So if you're staring at your phone or if you have headphones in, take them out. But this should already be answered, so let's go over it. Jada has $20 to spend on games and rides at a carnival. Games cost $1 each and rides are $2 each. Which equation represents the relationship between the number of games, X, and the number of rides, Y, that Jada could do if she spends all her money? So don't call it out. you didn't decide now. Remember, on a test, you don't leave easily, so you don't know the best guess. Raise your hand if you think it's equation A. Raise your hand if you think it's equation B. Raise your hand if you think it is equation C. All right, so more hands on the C. Definitely need to get some more participation in. But yes, equation C is correct out of the three. And why is it this one versus the other two? Question, Amari? Oh, you're gonna answer this? Okay, sorry, I thought you had equation. But why is this one the one that represents the situation instead of the other two?
Well, because the first one doesn't have a number for the variable in the represented or how much the cost is. For B, the number is pushed up because X is for the gain. And I talked one number, while C is equal to the line and it's $2.
Good. So then that kind of leads into this next part, which I'm going to ask you to think about and then discuss in your team. What each of the other two equations could mean. So this one shows me that games cost $1 each, rides cost $2 each. What does the 20 represent? The total amount. So usually on your equation, the part that's alone is usually a total of something, right? So then think about it first, what these other two could represent in this situation. And then discuss in your trios, or some of you are in pairs, discuss what A represents, you think, and what B represents. So. Then within your group, decide who will share. Doesn't necessarily mean I'll pick every single person to share. But I should have one person from each group with their hand raised. Ready? Decide who that'll be. All right, now let's see the reporter in your group. Doesn't mean I'll necessarily pick you. I may. But who should be one person from each group? It should be a hand raise of one person from each group. All right, Allison, what does equation A suggest about the situation? How much money she spent total? And then we also so on this side, so this one is how much money she has afterwards. Yeah. All right, let's see those hands again. Anthony, what would you say that A suggests about the situation? So you thought which part of this is how much you spent on the ride? The 2x. So let me just kind of remind you, what does X represent in this? The gain. And what does Y represent? Number of rides. So these are all really similar to our answer, but like in situation A, how much do the gains cost? And how do you know it's $1? What is the number in front of a variable if it's not written? It's time to water, right? What's the number in front of a variable if it's not written? 1. So then how much do the rides cost in this situation? $1. What about in part B? Or in equation B? What is this telling me? That the gain costs $2 and the ride costs $1, which is not what it assigned us. That's why these two weren't the right answer. We said that gains were $1 each and the rides are $2 each, which makes sense for these. So do you know the name for the number in front of the variable? What that is called? The coefficient, yes, someone said it.
Oh, yeah.
So coefficient, you can see that the coefficients tell you something about the relationship, right? So like that gain costs $1, rise costs $1, and so forth. So remember that. Because our next activity, you're going to be assigned a new equation, and I'll tell you which one your group is. And this is on the back of your note sheet where you can put your answer. But here are 3 equations. Each represents the relationship between the number of gains X, the number of rides Y, and the dollar amount a student is spending on games and rides at a different amusement park. So if you are on this side of the room, along the wall, you'll be equation 1. If you're in the middle, you'll be equation 2. And then if you're on this side, you'll be equation 3. All right, so that will be your assigned equation. Just like how you dissected the coefficients from the warm-up, is how you should dissect the coefficients from here. So what did we say X represents? Gains, and it also says it here again. What does Y represent? Right. So within your group, you're going to answer the questions that are on the back of your note sheet. I know it's like 7 questions total, right? We're gonna kind of piece it piece by piece. So answer it on your paper first, and then I'm gonna get you in a pair deck. Display your answer. So within your team, work together to answer the questions that are on your note sheet. Let me go back to the. There we are. So again, no one knows it's you unless you like shout out and say that that's me. So no need to be shy or erase your answer just because it's on the screen. But if you had this equation, this was equation 2, right? So everyone in the middle, pay attention. We're going to see if this is right. So when it says, what's the number of rides the student can get on if they don't play any games? So do we know the number of rides? Yes, or is that what we're solving for? That's what we're solving for. So in our equation, that should still be X or Y. Y is for rides. The X would be what if they're playing no games? It says if they don't play any games, so then how many games is that? 0. So what you should have done is plugged in a 0 for the X initially for number 1 in whatever equation we had, and solve for Y because that's what we're trying to discover, how many rides it can go on. You might have even thought about it logically too. All right, but 2.50 times 0 is 0 plus y is y, so then it's just y equals 15. So you guys are correct. Good job. And then for the second part, what's the number of games the student can play if they don't get on any ride? So in this case, what is 0 for number 2? This is number 1 up here. For number 2, what is going to be 0? The x or the y? The y, because this time they're not getting on any ride. So x is still x, that's what we're solving for. The y will now be 0. And what's it equal to? 15 still, that's part of our equation. So 2.50x plus 0 is just 2.50x. How can I cancel out that 2.50? What's it doing to the x right now? So to undo it, do the opposite. What's opposite of multiplying? So we're going to divide 2.50 on each side. This group said that it equals 6. Is that correct? All right, so this is correct. Now for the coordinates, if you remember, how do we label coordinates? Like what goes first? It goes in the order of x, y. So in the first one was the x0. Yes. Was the y15? So then this is also the correct coordinate. For the second one, was the x6? Was the y0? So then that is the correct coordinate. So if you had equation 2, fix it. If you got it wrong, then these are the correct answers. Now for the graph, we need to fix that part. All right, let's see if another group has that part correct. So I'm going to kind of put an X over the graph. It is going in the correct direction. It is decreasing. But let's see if there's a better one. Better. That one looks the same as the other one. Wait, let's see. That again, that one looks the same as the other one. That one's a different equation. Again. Yeah, okay, so let me just pick one that looks similar. So my first coordinate, we said x was, it was 0, 15, and the other coordinate should be at 6, 0, right? 0, 15, so this is my x-axis, this is my y. Here is 0 on the x, here is 15 on the y. So it should touch your y-axis. You remember what that's called when it touches the y-axis? It's my y-intercept. So this right here is my y-intercept. Anytime that x is 0, that's your y-intercept. This one, so x is 6, find 6. It goes up 0 on the y. If this is my y-intercept, what do you think this one's called? It's the x-intercept. Not sure if you've done much with that in the past, but you're going to start now. So that is my x-intercept. Whenever y is 0, that's your x-intercept. So if you ever need to solve for x and y-intercept, you can just do what we did in the first 2 problems and solve that way. And then number 3 said to draw the lines to connect. I'm really bad at drawing straight lines on here, but it should look something like that. All right, so I'm gonna kind of cross out this line before I think I will make sure to start. And now let's look at the other equations that we're out there. So let's see for equation 1, I think is next. Yeah, so this one is equation 1. For them, when I plug in 0 zero for the x, so that would be for the game. It would look something like this. 0 plus y equals 20, so what does y equal? Class, you can help even if you didn't have an equation. What should y equal when we plug in 0 into this equation? 20 is correct. Because you're plugging in a 0, because they didn't play any games, so 0 for the game, like here, with 0 plus y. With 0 plus any number, that number. So 0 plus y is y, and then y is by itself, so it must equal 20. Okay? So then when I put my coordinate for that one, is it 20, 0 or 0, 20? 0, 20 for the first one. Then x was 0, y was 20. Now plug it in for the y when they don't go on any ride. So x is what we're solving for. Y will be 0. What does x equal? 20. Was x is 0? Whole class, x was 0. Are we alive out there?
Yep, I'm here.
What's 0 plus any number? That number, whatever it is. So x of 0 would be x. So then x is now by itself, so x equals 20. For number 2, what would the coordinate be? 0, 20 or 20, 0? 20, 0. So the number 2, x was 20 and y was 0. Again, this graph is a little bit off. So to fix it, where should the dot be for the y-axis? Karen? Okay, what are you doing? So this is equation 1. This is the ones that you guys have. So everyone's had like different. So that's why. So for those of you that had equation 1, which I'm pretty sure I assigned it to this side, these are your right answers. The first one would have had a coordinate of 0, 20, and then plug in 0 for the x, y is 20. And then same when you plug in 0 for the y, x happens to be 20 also. But you write it like this because the coordinates go x, y. Make sense? So then this graph is incorrect. We need to fix it. Where should the dot go? On the 20. Because 0 up 20 for this first point. Where should the other point go? Down here on the x-axis where the 20 is, so that's where it would be 0. And then draw the line to connect them. That I'm really bad at drawing. Do that. All right, but that's the answer if you had equation 1. Questions on equation 1. Now let's look at equation 3, although I wasn't seeing that on here. Okay, here's one of them. So here's the equation for equation 3. So in this case, when they go on, when they play 0 games, where would the 0 be plugged in? For the x, so it's 0 plus 4y equals 28. What's 0 plus 4y? 4y. What's opposite of multiplying by 4? So do that, whatever you go on one side. And y equals 7. So 28 divided by 4 is 7. So they got it correct. What would the coordinate look like for number 1? 0, 7, because that's x was 0, and y we solved for was 7. Now in the second one, what are we plugging in? the 0 and 2. Here's for number 1. For number 2, we plug in the 0 where? For the y. So it was x plus 4 times 0 equals 28. What's 4 times 0? Was x plus 0, x, and then x equals 28. So good job. What would the coordinate look like? 28, 0 is correct. So then again, I'm not sure why does it look like this on your screen too? I don't know. Maybe it's just hard to plot on these little ones. I don't know. But the correct placement would be where for the y-intercept? Good. And where on the x-intercept? 28. And I can't see the numbers. But wherever the 28 is. And then you draw a line. I don't know where the 28 is. Sorry. There you go. Second to last one. Okay. Why would you do that? Can you undo that?
Yeah, I was just doing that. You didn't do it, like,
Oh, so it's you're drawing it the right way, it's just not taking it. Is that it?
It's slowly.
Okay. All right. So let's do all right. So questions on the first part. All right, the next part is a little more tricky because I know we might have forgotten something. So let's try the second part. Sorry, okay, fine. So now here's the second part. It's also printed on your paper. But try this out. For your equation that you were assigned, complete these sentences. Hopefully you got that. And then based on the correct way your line should be drawn, calculate the slope. Do you guys remember how to find slope of a line?
Rise over run.
Rise over run is how you identify the slope. So slope we label M, rise divided by run. You can count on your graph, do your best. And then if you do that, try rearranging to solve for y. I'll give you like 3 minutes, and then we'll move on to the third. So equation 1, if they played no games, we discovered that they could get on 20 rides. Why? Not why. Right? Because y equals 20 when we solve for it. Now you can tell that. So it says for every additional game the student plays, the possible number of rides decreases because our graph is going down, correct? We call that having a negative slope. So when it decreases, it's a negative slope. And how do we know that it decreases by 1? Yes. Because that is how much each game is. All right, so each game is $1. So then if I decide to play one more game, then that means that the ride decreases by 1, right? Because they both actually cost $1. So good, correct. This is correct. Now for the slope, let's see. I actually really like that this is a nice straight line because I can actually just use this graph. Whenever you're finding slope, stop talking right side of the room. Whenever you are finding the slope from a graph, you want to look for points that go through what I call crosshairs. So like where it looks like the line or the point is going through the center of that T on your grid. So I could use like my y-intercept, for example, what's this coordinate? Is it 20, or 0, 20? And then it looks like it goes through this point right here. What coordinate would that be? And this one is 218. I don't really need the values of it, but I'm just showing you. What you can do when you have a graph is make a triangle and count your rise over your run. So then count how much am I going down for my rise? Because rise is up or down. 1. But look at the numbers. 2. So it's kind of numbered a little bit differently. So pay attention to that. And since it's decreasing, I should put a -2. What's my run right here? 2. So then again, because it's numbered a little bit differently. But then when you simplify this fraction, what does it simplify to? What's -2 divided by 2? -1. So that is my slope. Where it intersects the vertical axis, so this right here, the y-axis, is at 0, 20. And notice, compare it to when we said it decreases by, it does decrease by 1. So that has a relationship. The rearranging to solve for y, what are they asking you to get by itself? When I say solve for y, I want the y to be by itself. Yes. So how can I get rid of the x that is next to it? How can I make x 0? Subtract x. That's what you do on one side. Do it to the other side. So then I get y equals 20 minus x. But what if I write it like this? Y equals -x plus 20. Is that the same thing? Yeah. Does this look familiar at all? It looks like y equals mx plus b, which is also how you graph linear equations. Because the slope we said is -1. The y-intercept you said is 20. So it all comes together. Make sense? That was the whole point of doing that. Is to see that they're all related. So that could be your connection. Questions on example 1 or equation 1? All right, this was like a really beautifully drawn graph, so that helps. Let's see if I can find a salvageable one for the other. All right, so this one looks good, except it's missing the graph. Can you guys give me the graph on here, whoever this is? But no, you guys, let's go back and what's good. Anyway, here's equation 3. So if you had equation 3, this is what it looks like. For when they play no game, so x is 0, we solved y and it was 7. So that makes sense. It did decrease because the graph would go down. I don't know that it decreases by 1 though. So kind of table that. We'll fix that. For the slope, so I'll graph it using y-intercept again. So it was 0, 7, and then the x-intercept was 0, 28. Can you make that nice straight line? Whoever can graph it. Yeah, like is there like a line tool on your screen? Maybe like a skinnier line. This is the line. Oh, it's because you're doing it on your phone. Okay. Sorry. Okay, let's try it from Desmos. So I'm just gonna copy the equation in Desmos so that I can have a nice straight line. I understand the issue now. It's not interesting. Okay, so I'm gonna copy that equation. I'm just gonna type it exactly how it looks in our paper, right? And now it's graphed for us. Here's a little Desmos hack for you. For the graphing of the slope, you're gonna wanna pick 2 points where it looks like it's going through a crosshair. So like I'll pick the y-intercept because that's definitely going through like the T. Where else could I pick maybe? Maybe here. Maybe I could pick down here. It doesn't really matter which point I pick because you just will draw a triangle and count your rise over run. Focus. What's my rise in this one?
One.
So see how this one's counting. It goes 5, 6, 7, 8, 9, 10. So normal. And should it be positive or negative? It should be negative because we're actually going down to get from the left to the right. Make sense? Yeah. Anytime your rise is going down to get to the next point, like how you read, like from left to right, anytime you're going down, it will be negative. Because the slope is negative, it's a decreasing line. Make sense? What's my run?
4.
-1/4. So remember that. If I go back to what we said, isn't this equivalent? -0.25? It is, in case you were wondering. Put it in your calculator, you can see for sure. -1 divided by 4 is -0.25.
Students and staff, this is Mr. Cuckold, staff. We're going into a shelter.
So that is our slope, the -1/4 or this as a decimal. So then to fix this up here, it's decreasing by 1/4. I wouldn't say it's decreasing by -1/4 because the decreasing already established. Does that make sense? So that has a relationship there too. For the rearranging, do you think that they rearranged this correctly?
No.
So let's see. We want to solve for y, which means we want the y to be good by itself. Wrong. First, get rid of what's farther from the y. Would that be the 4 or the x? So how can I cancel the x? Whatever you do on one side. So that cancels. The y is not by itself yet. So that's why we're not done. How can I cancel the multiplying by 4? Right. Good. Whatever you do on one side, do to the other, and you have to do it to the entire other side. So if you want to like split it up, that's what I usually see people do. Because you can do 28 divided by 4. What's 28 divided by 4? 7. And then this is basically negative x/4 or -1/4 x. So that is it rearranged. If you want it to look more like slope-intercept form, then just change the order. Put this one first, but still make sure it's negative. Put that one second, and just make sure that it's still positive. Both are equivalent. And that's what we said. We said that the slope was -1/4. And the y-intercept is, we didn't re-say it, but it is at the 7. That makes sense? Yes. From the rise over run. From the decimal. All right. Question? Let's look at the last one, which was, I forget what these are. This one looks neat, so let's try this one. I can't remember if this is the right answer. Is it?
Yes.
Okay, this is incorrect. It should decrease by what instead?
Oh, that is 10.5.
It decreases by, because that's your slope. That's your rate of change. Mind blown? I think that's, I don't know. I guess you have a point there. Ryan said, how can you decrease by half a mile? Which is a fair point. So I can see why we rounded it up to 3. But just go with me. It's the rate of change. It decreases by $2.50. All right. So then, yeah, to find the slope, we could use the y-intercept, which definitely goes through a nice point. That's 0. And then what else looks like it goes through a nice point? This one. So then make your triangle. What's my rise? Good. Note the difference in the numbers here. And then what's my run? That actually looks more like 5. Because it goes 1, 2, 3, 4. I don't know. This graph might be a little bit off. Because it should be 2.5. Let me try typing that in here. The 2.50 plus y equals 15. All right, and then when you count the rise over run and some points that go nicely through it, it ends up being -5/2 actually, which is 250. Sorry. It's hard when it's like not a perfect, like a graphing technology type graph. But yeah, then when you rearrange it, do you think that they rearranged it correctly? Yes, no? The rearranging is correct. If you want it to look more like slope intercept form, then just change the order to make the x term go first. So y equals -250x plus 15. The 250 is still negative, the 15 is still positive. Good, any questions? All right, don't lose your papers. I'll end it there. Just hang out, don't leave.